Sorry, there was no dramatic intermission for that one. Just ran out of time. All right, so we were calculating integrated rate. We're using integrated rate law to determine K value on the last one. Now we're asked to determine the concentration of nitrogen, dinitrogen pentoxide at 600 seconds. Well, what does that mean? What are we being asked to find? Concentration, well, what we've graphed here is the, oh, my calculator shut off. What we've graphed here is the natural log of the concentration. So whatever we get from our graph, we're going to have to get rid of that natural log. And remember that natural log is on the y-axis. So we're asked to find what y would equal at, and 600 seconds, time is always going to be our x-axis. So essentially we're being asked to determine what y is if x is 600, or what ln of x, or what the inverse of the natural log is going to be. All right, so we figured out that, we've got a y equals mx plus b. You can just take that and plug and chug the values to determine what y would equal. Because you could take this, multiply it by your value for x, and add an initial concentration. Done. You could do that way. Or you could have the calculator do it. The calculator is more than capable of doing this for you, and it's more than happy to do it. Just requires a couple more button presses. So in the last entry, I did the linear regression of time versus the natural log. I also want the calculator to take that value and put it into y for me so that it will automatically graph it. So if I put another comma here and hit vars and go over to y vars and I say I want you to put that into a function calculator, I want you to put it into the first function. So I hit enter. It's going to take this y equals mx plus b and put it into my first value for y. So if I hit enter here, it's going to do that. And now if I hit y equals, what do you know? It's got that whole thing in there for me. I could also hit second and y equals, that'll bring me to the stat plot, and turn on one of these plots. Let's turn on plot 1. So I'm going to turn this plot on, and I want it to do a scatter plot. But I don't want list 1 and list 2, I want list 1 versus list 3, because list 3 is where we stored the natural log. I hit enter again. Enter should take me out of here, I think. If I hit graph, I'll get something that looks like this, except for it might not look like this because I paused you while I did a very critical step. Originally, you wouldn't be able to see your line graph because your window is too small. So I'm going to clue you in on a little secret that the math department has been holding out on you. If you hit zoom and hit zoom and go all the way down to zoom 9, that's zoom fit. Or sorry. Zoom 0 will make it so that the window fits all of your data points. So now you can see your line graph. If we want to know the value of x at any particular moment, we can have the calculator calculate this by hitting second and the trace button to bring us to the calculation screen, and hit enter on value, because we're going to say, I have a value for x, tell me a value for y. So I want a value of 600. I hit enter, and uh-oh, something's not right. It says invalid. Well, what's invalid, Compy? This number's invalid. Well, there's a reason for that. If I look at the window, this thing is maxing out. The maximum size of this window is 440. The computer says, I'm not going to make this window any bigger than 440. And that's not going to work for you. So we're going to zoom again. We're going to go into zoom, and we're going to zoom out now. Because we're too close in. We want to zoom out a little bit. So zoom 3, hit enter twice, and it will zoom your data out. Man, does it zoom out far. Now let's try that again. So second trace to get to the calculate screen. Hit enter because I have a value. I'm going to put in 600. Hit enter again. And when x is 600, y, so this y is negative 6.466, or 6.46, blah, 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 blah. The calculator automatically stores that value into this alpha key y, which is right here. So we can now take, if we want to get rid of the ln and just find the concentration, we're going to do, what's the opposite of ln? It's directly above it. You're going to raise e to the value of that y. So I hit second quit, get out of here, and I'm going to raise, so second, and then hit ln to bring up that lowercase e. I'm going to raise that to the alpha button, and I'm looking for y. Hit enter. And when x is 600, so at 600 seconds, we have a concentration of 0.00156. And I can go ahead and add that to my data table because, hey, look, I've got some data here I'm predicting. So I'm going to put that on there as well. And that is in line with the data I got before. So notice how it's decreasing at 600 seconds. It only makes sense that it would be a lot less than it was at 400 seconds or 300. All right, on to the next one. And gosh, I wish there was an easier way to do this next part, because whereas before we could just hit second calculate and our second trace and say I have a value for x, because now we're saying what is the value, at what time is the concentration equal to 0.00150? That means that I'm looking for an x value and I'm given a concentration. But remember, our graph isn't of concentration, it's of the natural log of concentration. So let's take this value and figure out what y is. And we find that y is negative 6.5002 or 022. All right, so we have a value for y. We need a value for x. So if I have a y equals, well, there's a y equals button right here. Let's put something in that. So the second one on here, y equals, so let's put this value in here. Let's put ln 0.00150. All right, so now the computer's going to graph what that value is on our graph. If I hit graph, it's going to take me there. And look, there's our line being made of at that molarity. We want to know what the x is. So if I hit trace, it will let me move around, but I want to know the exact point. So I can calculate that, again, with second trace. If I hit second and trace, I can find the intersect of those two lines. And you're pretty much just going to hit enter until it says intersect, because it says, oh, this is your first curve. And you say, yes, copy, that's my first curve. Oh, that's your second curve? Yes, copy, that's my second curve. Would you like to guess? No, I don't want to guess. I want you to guess. Hit enter again, and it will think for a few minutes, and it will say, I know what the answer is. And it says these two lines intersect at 605.9. So that means at 605 seconds, or 606 seconds if we want to round in line with the rest of the table, 606 seconds would be the time at which we would have this concentration. And for posterity's sake, let's put that into our graph, into our table up here, and make sure that makes sense. That kind of follows in line with the rest of our graph, or with the rest of our table. So I would say that that answer is very probable, and I think we're pretty much done. Now I've got great news. If you've been following along at home and either you don't have your own calculator or all this second everything buttons are driving you crazy, if you open your packets to page 10, I believe, this is where these notes begin. Oh, page 9. Page 9 of your Mimsy notes on kinetics has all of these directions written out in nice, pretty format, and they even have the buttons drawn in there, so there is no excuse. Again, we could have figured out these bottom two questions just off of our formula, y equals mx plus b. However, where's the fun in that when we can get a calculator to do it for us and save us some time?